In this session, I will start discussing from the conditional probability. Suppose that we are having two events named as event A and event B. Suppose that we are having two events, event A and event B. And if you suppose that the occurrence of event B is affected by the occurrence of event A, then we are calling such events as the dependent events. It is quite like this. Suppose that you are getting heavy rains. Suppose that you are getting heavy rains in your area, and suppose this will be the event A, and we'll take event B is getting floods by the following day. Getting floods by following day. So, then if you consider about these two events, event B and event A, this event B is depend on event A. It is because if you are getting heavy rains in your area, then you will be having a situation of getting floods in your area. If you are not getting heavy rains, then there will not be floods in your area. Therefore, the occurrence of event B has affected by the occurrence of event A. Therefore, this type of events are said to be dependent events. It is because one dependent events. It is because one event is affected by the other event, or else one event is depend on the other event. Therefore, such events are said to be dependent events. For such dependence, for the dependent events, we are defining a concept called the conditional probability. It is actually we are finding, if you know that event A is already happens, then we are trying to find out what is the probability of happening of event B. Therefore, it is the simplest idea behind the conditional probability. Suppose that you are having two events. Event A is priorly happened to the happening of event B. Then if you need to identify the chance of happening event B, if it is given that event A is already happened, to identify or to calculate this value, we can use the concept called the conditional probability. For the calculation of the conditional probability, you can use the equation. Here the equation is given. We are pronouncing this as probability of B given A. Here A is the given event. It means that A is the event which has occurred prior to the occurrence of event B. Therefore, we are pronouncing this as probability of B given A. Given A means the A is the event which has already occurred, and this can be expressed using probability of B intersect A. Probability of B intersect A or probability of A intersect B, then divide it by the probability of priorly happened event. It is the probability of A, and we can use this conditional probability if you know that probability of A is greater than 0. If this value becomes 0, it means that exactly we know that event has not happened. Therefore, if one event is not happened, then other event cannot be happen. It is because if you are not getting heavy rains, there will not be any floods. Therefore, in such situation, we cannot define the concept of the conditional probability. Therefore, what we have to use is we can use this equation by conditioning on the probability of A, or the probability of priorly happened event is greater than 0. Now we will discuss about the independent events. Now think about in this situation, what we have observed was event B has affected by event A. But suppose that you are considering any two events. the occurrence of one event does not affected by the occurrence of the next event, then such events are said to be independent events. If you are getting the same example, if you suppose that you are getting event A is getting heavy rains to Sri Lanka. Heavy rains to Sri Lanka, and suppose that event B is getting floods in USA. Suppose these are the two events. These two regions are actually far away from each other. Then we can see that the occurrence of event A is not affected by occurrence of event B, or vice versa. It means that occurrence of event B has not affected by the occurrence of event A. In such situations, we are calling such events as the independent events. Therefore, we can say these two are independent events. These are independent events. It is because occurrence of one event does not affected by the occurrence of the next event. Therefore, if you are considering these independent events, we can extend the concept that we have defined under the conditional probability in this scenario, and using that we will able to obtain new equation for the intersection of such two independent events. Therefore, what we can use is, actually we are defining the conditional probability for dependent events. But suppose that these are two independent events, and if you are taking this conditional probability, if you are conditioning the occurrence of event B on A, if you consider that these A and B are two independent events, then what we can get here is probability of B given A. Even though A occurred or not, B can occur independently. Therefore, this can be say as probability of B. It is because even though the event A happens or A does not happens, then we know that this event B is happening. Therefore, the happening of event B is not affected by happening of event A. And vice versa, if you are considering in this way, suppose that event B is the given event and it is given that A and B are two independent events, then such situation we can say that this is equal to probability of A. It is because that these are two independent events. In other words, we can say that the occurrence of A is not affected by B, and therefore we can say that either B happens or not, the event A is happening. Therefore, the chance of happening of event A is not affected by happening of event B. Therefore, if you consider on this equation, suppose that this is our first equation, and I will take this as the second equation I am considering. If I write it here rather than mentioning there, suppose that this is what we can identify if these two events are independent. But according to the previous definition, we know that probability of B given A can be written as probability of B intersect A, or probability of A intersect B divided by probability of A. Suppose this is numbered as equation number 2. Now what we know that for this the left hand side of this equation, we are having the notation probability of B given A. Therefore, instead of this part, what we can substitute is we can replace it by probability of event B. Therefore, instead of this probability of B given A, we can use probability of B. It is because A and B are independent event. By considering this equation, we can obtain this as probability of B given A divided by probability of A. Therefore, if two events are independent, then we can obtain a quantity for the intersection of these two events. Then if you do the cross multiplication, then you can subject this quantity probability of B intersect A is equal to probability of A times probability of B. Therefore, this is one important equation which we have to use in the calculations. Therefore, We can use this equation in the calculation of the probability of intersection of two events if it is given that these are two independent events. Now I will discuss an example related with these independent events. And there are some other two. I will take the first example and you can try for other two examples by yourselves. According to the first problem given for us, it says that there are two students naming student X and student Y. And it is given that these two students are working on a problem, and it says that the probability that X will solve the problem is 3/4, and the probability that Y will solve the problem is 2/3. Then they are asking what is the probability that the problem will be solved. Suppose that X is taken as probably the event of X solves the problem. Event of X solves the problem. And we'll take Y as the event of, we'll take this as the event of Y solves the problem. Now, according to this given situation, these X and Y are working independently. Therefore, we can consider that X and Y are two independent events. X and Y are two independent events. X and Y are two independent events. Then what we can do is here we need to identify the probability that the problem is being solved. If you just interested in the problem is being solved, what we can consider is to get the problem solved, it can be solved by X or it can be solved by Y, or else both of them can be solved. Therefore, in these three ways, we can get this problem solved. Therefore, what we can consider here is, here we need to calculate the probability that X or Y or solving this problem. Therefore, we can write it prior to discussing about the probability. I will write the event that X or Y or both solve the problem is what we need to identify. It is because if you draw this using a Venn diagram, here what we need to identify is if this is X and if this is Y, then X or Y or both solve the problem is being solved. Therefore, what we need to identify is we need to get the probability of X union Y. This is what we need to identify. When we are discussing about this rules under the axiomatic approach of probability, what we have identified was probability of X union Y was identified as probability of X plus probability of Y minus probability of X intersect Y. So far, we are knowing about the value for probability of X. It is because it is given that the probability or the chance that X solves this problem is 3/4. And we know the probability of Y solves this problem is 2/3. But we need to, this part is, we know for the probability of Y, we know, but for probability of X intersect Y, still we are having a question. It is because we do not know what is the value for probability of X intersect Y. But the clue is given for us that X and Y works independently on this problem. Therefore, instead of this intersection, what we can write is probability of X intersect Y. We can obtain this as probability of X times probability of Y. It is because we know that if these are two independent events, the intersection can be obtained as multiplication of the probabilities of those two events. Then this can be obtained as probability of X. It is 3 over 4. Then this is multiplied by 2 over 3. Then if you solve this, then you will be end up with this calculation as R. Now you can do the substitution in this equation. If you if I rewrite the equation here, then I will get this as probability of X union Y. It means either X or Y solves the problem. Then this is equal to probability of X plus probability of Y minus probability of X intersect Y. Now we know all three values. Then this we have to do the substitution. It is 3 over 4 plus 2 over 3 minus 1. If you perform the calculation, you are having 3 over 4 plus 2 over 3 minus half gives you the value as 11 divided by 12. 11 divided by 12. No need to convert this into decimals. We can keep it as a fraction since we are identifying the probability values. Then we can say that the probability of the problem will be solved is 11 over 12. Therefore, this is the answer. It means that the problem is being solved is either X has to be solved the problem, or else Y has to be problems, or else both of these systems can solve the problem. Therefore, considering that scenario, we can obtain the probability of problem is getting solved. This is how we are using the concept of the independent events in the practical approach, and you can try these two problems by yourself and please have a look at about these two problems and try to obtain the answers for these two problems as well. And now we will move for the next important concept in the probability. This is called as the total probability law. Therefore, this is one of the important concept used in probability. Here, we will actually, this is also based on somewhat the conditional probability and mutually exclusive events and exhaustive events. All these concepts are used under this total probability law. Therefore, if you consider this total probability law in this way, suppose that you are having n number of mutually exclusive and exhaustive events. Here we are naming them as A1, A2 up to AN. Those are mutually exclusive. Mutually exclusive in the sense there is no any intersection between any two given events. Therefore, we can say that these are mutually exclusive events, and exhaustive in the sense there is no any other event apart from these n number of events to complete the sample space. And we will suppose another event as event B. It is an arbitrary event of this sample space. Then what we can identify this here, if I write it or if I draw this using a Venn diagram, what I can obtain here is, if this is our sample space, we are having n number of mutually exclusive events. It means that this sample space can be divided into A1, A2, A3, A4, A5. Likewise, we can have n number of events. Check this AN. We are having n number of events. Suppose that we are considering another event inside this sample space S, and suppose that we are making this as the event B. We will take this as event B. This is what we are considering as event B. Now, what we are going to do under this total probability law is we are going to identify the probability of occurrence of the event B. Probability of occurrence of event B. To calculate the probability or the calculate the chance of the occurrence of event B, what we can consider is we can consider the collection of these small intersected parts. Actually, if you consider about this probability of B, if you consider about this probability of B, what we can write here is probability of B can be written as this small part can be considered as probability of B intersect A1. It is because there is a small intersection part from A1 with B, and this is added to probability of B intersect A2. It is because if you see about this, now think about A2 has intersected with this part, then A2 intersect with B. Likewise, we can now we have added this part, then we can add this small part, it is A3. If you write it, then you will get this as probability of B intersect A3. Likewise, we can add the probability of B intersect A4. Likewise, we can move up to the addition of probability of B intersect AN. Therefore, if you consider, if I draw or if I color these intersected parts, then this is for A4, then here it is for A5. Likewise, this part is for AN, then intermediate parts covers this area. Therefore, now you can see that the total probability of the event B has obtained based on summing up the intersections of these small or the intersected areas. Then what you can do is, here we'll consider that event this AI has already happened events. Therefore, we can now consider the dependencies on these two events, A1 with B, then A2 with B, A3 with B, up to AN with B. Suppose that instead of A1, A2, A3, I will take AI as a common notation, and we can say that each AI and B are dependent events. This is what we can dependent events. Therefore, based on this concept, we'll define this total probability law. Therefore, what we can write is, instead of this intersection, what we can do is, if you refresh our mind regarding what we have written as probability of B intersect A, what we have taken as probability of B given A, not the intersect A. Probability of B intersect A was obtained as probability of B intersect A divided by probability of A, which the A is the already happened event. Here we will consider this A1, A2 up to AN are mutual exclusive, exhaustive. Those are the events which have already occurred prior to this event B. Therefore, what we know is, we know this intersection. Therefore, here I will subject this intersection quantity. Then I will get this as probability of B intersect A. Then this is equal, using the cross multiplication, I can get this as probability of B given A times probability of A. Now, if it is a single event as A, we will define this. But now what we are having is, for each of these AI, we have to do this similar thing. Therefore, what we can obtain here is, if I write it here, then probability of B can be written as, for the first event of A, then B intersect A1 can be written as probability of B given A1. Probability of B given A1 times probability of A1. It is based on the equation that we have used here. Instead of this intersection, we are using this equation. Then this is added to probability of B intersect A2 times probability of A2. Likewise, we can consider for the third event, B given A3 plus then probability of, if it is the nth event, B given AN times probability of AN. Therefore, what we can see is, here we can see the similar pattern, probability of B given ith event of A times probability of ith event of A, and we have taken the summation of those events from 1 to n. Therefore, what we can do is, here we can write this as probability of B is equal to summation. Instead of these addition marks, we can write this as a summation. It is because we can convert this into a common form as we can write this as a common form. It is probability of B given AI times probability of AI. Here we have to take the summation from I goes from 1 to n. Therefore, we can write this as I goes from 1 to n. Then this can be considered as the total probability law. Now we will move for the next theorem. It is called as Bayes theorem. Actually, based on the law of total probability, we are going to obtain the Bayes theorem. For a gratitude for the person who has found out this theorem, the person Bayes has found this theorem. That is why it is named as the Bayes theorem. Then what we can, it is actually combined with this total probability law. Therefore, what we are going to do here is, if I draw this using a Venn diagram, suppose that A1, A2 up to AN are mutually exclusive and exhaustive events. Suppose that it is quite in this way. Here we can say that this is A1, A2, A3, A4, this is the nth event we are having. Now we need to find out, it is given that these are mutually exclusive, therefore no any intersection, and these are exhaustive events. It means that there is no any other events which covers our sample space, and we are selecting another arbitrary event. We will consider another arbitrary event as event B. Let this as the event B. Now what we are going to do here is, suppose that event B is the event which has already occurred. In the previous one, we are considering the laterally happening event is event B. But in the Bayes theorem, we are considering, suppose that event B is already occurred. Then, using the Bayes theorem, what we are going to identify is what is the probability, if it is given that event B is occurred, what is the probability, or actually simply what is the contribution for this event B from each single unit. If here you consider about this small part, here but using the Bayes theorem, what we are going to identify is, if event B is occurred from event B has already occurred, then what is the probability of occurrence of it from A1. Therefore, using this concept, the Bayes theorem has defined, and here I am not going to discuss the proof of the Bayes theorem. Here I will directly write the Bayes theorem. Then what we can do is, here what we know is B is the event which has already occurred, and now we are going to identify it is getting from the ith unit of, or the ith section of A. Therefore, it is called AI. Then this can be obtained as, using this concept, here we can take this as probability of B given AI times probability of AI divided by probability of B, and this B can be obtained using this total probability law. And we know that probability of B is greater than 0. It means that we know that B is the already occurred event. Then instead of this probability, probability of event B or the priorly happened event, we can substitute this quantity from the law of total probability. Then we can get this as probability of AI given B is written as probability of B given AI times probability of AI divided by summation I goes from 1 to n. The similar quantity will be appear when B given AI. Therefore, this way or this way you can use this. Here what we know is if you know the total probability of this event B, then you can use this equation, or else if you do not know the value for the total probability of B, then you have to replace it using this equation, which is obtained from the law of total probability. These are the two concepts which are used in probability. If you are conditioning on events, then total probability law and Bayes theorem is widely used. And then we will discuss an example related with the total probability and Bayes theorem. And the next important thing under this section is here what we need to do is, first of all, you need to identify what are the priorly happened events and what are the laterally happened events. And you need to identify which are the exhaustive events, which are the actually mutually exclusive and exhaustive events. Therefore, those things has to be actually you have to have an idea prior to go for an calculation based on the total probability law and Bayes theorem. Now we will discuss an example based on this total probability law and Bayes theorem, how to apply these two concepts if it is given in a problem. We'll discuss that matter as well. Okay, now this is one example given that a company has, suppose that a company has 3 machines named A, B, and C. There are 3 machines named as A, B, and C. If I write this information, there are 3 machines A, B, and C. And it says that machine A produces 20% of the total production, while B and C produces 30 and 50%. Therefore, it says that there are 3 machines, machine A, machine B, and machine C, and this gives the 20% of total production, this gives 30%, and C gives 50% of total production. Now, if you see about these 3 machines, now you can see that these 3 machines are working independently, therefore no any intersection. Rather than saying independently, there is no any intersection in these 3 machines. It is because A produces items separately and it is not having any this intersection with the machine B or machine C. And for B and C, the same scenario is there. And the next thing is we can consider these are exhaustive events. It is because now if you consider that addition of these 3 values gives us the total production. It means that there is no any other, there cannot be any other machines which use this total production. Therefore, this machine A, B, and C along with these 3 machines gives the total production. Therefore, we can consider that A, B, and C are. Therefore, we can say that A, B, and C are mutually exclusive. These are mutually exclusive events. as well as these are exhaustive events. Exhaustive events. Now we have identified the first part, and then we are saying that there is a defect on the production, and there is an associated rate for each machine for getting a defect product. It is because if it is a machine, generally we may not able to get exactly 100% correct items, so there may be some defect items as well. If it is according to the past experience, they know that the defect rate for machine is 6%. Then if you consider this next event as event D, then A has a contribution of 6% to defect, or actually rather than saying that, the machine A, if it produces 100 items, 6 will be defect item. Machine B produces 100 items, then 7 will be defect items. Likewise, the defect rate for machine C is 8%. Therefore, now we know the defect rates for each of these machines. Now, in the first part, it asks us what is the probability of, it's not if, what is the probability of getting a defect product. Therefore, here I am defining another new event. Event D is event of getting a defect product. Event of getting a defect product. According to the information provided for us, what we know is probability of getting a product from machine A is 20%. Here it is included. If I write it here, then we know these are the information we are having. Probability of getting a machine from a machine A is 0.2. It is because it is 20%. 20% itself equals to 100 divided by 20 divided by 100 itself equals to 0.2. Therefore, I can say probability of event A is 0.2. Similarly, I can write down probability of event B, getting a product from machine B, is 0.3. Probability of event C, getting a product from machine C, it is equal to 0.5. Now you can see that addition of this probability suggests that value is 1. It means these are again exhaustive event. And we know that the defect rate for each machine. Therefore, if you consider event D is the event of getting a defect product, what we know is probability of D given A. If you know that the product is from machine A, then probability of getting it as a defect product is D given A, and this quantity is or this amount is 6 divided by 100, which is equal to 0.06. Therefore, this can be considered as 0.06. If it is know that product is from machine A, getting a defect product is 6%. It is actually this quantity. Then probability of D given B, according to the data we are having, we know that it is 7%. Then probability of getting a defect product from machine C, it is 0.08. According to the information we are having, we know these values. Now they are asking what is the probability of getting a defect product. We know that this event D is the event of getting a defect product, and they are asking us what is the probability of occurrence of this event D. Then this is the quantity that we need to find out. Then what we can do is according to the situation, we have to arrange this equation here. Rather than saying as A1, A2, A3, here we are having A, B, and C. Then we can rewrite this equation in this form. This probability of occurrence of event D is equals to, actually this event D is it is coming from machine A, machine B, and machine 3C. Therefore, all three machines are contributed for this event D. Therefore, first I will consider the part from machine A. It is D given A times probability of A. plus probability of D given B times probability of A plus probability of D given C times probability of C. Here is not A, it should be B. Probability of D given A times probability of A, probability of D given B times probability of B plus probability of D given C times probability of C. Now if you substitute the values, then you can get this answer. D given A, the value is given as 0.06 multiplied with probability of A is 0.2. Added to probability of 0.07 multiplied with 0.3 plus 0.08 into 0.4. If you perform this calculation, here I have included this calculation steps. Therefore, we can see that this calculation gives gives us the value as 0.073. Therefore, this value is equal to 0.073, accurate to 3 decimal places. We have obtained the value for PD. This can be considered as PD. PD is equal to 0.073. This is the answer for the first part. They are asking what is the probability of getting a defect product. And if I move back to the second part of this question, it is given, they are asking that if it is given that product is a defect one. Now it is given that event D is the already happened event. It is actually like at the end of the day, you have, if you are manager at this company, then if you have, the workers have isolated these defect products, and at the end of the day, now you know that the product is a defect one, then you need to identify the probability of getting it from machine A. Then it is actually asking the second part of this question. Then what we need to do is we need to identify this probability. Now what we know is, we know that D is the given event, and we need to identify what is the probability of getting it from machine A. Then this is the quantity we need to identify. Then what we can use is Bayes theorem. It is because we are not going to get the total probability of an event. Here we are just finding out it is actually a partial contribution for a event. Then what we can take here is this probability of A given D can be written as probability of D given A. Just interchange these two terms, then multiply it with the laterally mentioned term divided by the initially mentioned term. It is actually the given event. Now it is no need to calculate these quantities, because in the previous step we have obtained a value for probability of event D. It is the probability of getting a defect product. Therefore, if you substitute the values, probability of D given A, it is given as 0.06. Then multiplied with probability of A is, it is 0.20. Then divide this by 0.073. Then this value, this calculation gives the value as 0.1644. It is if it is given that the product is a defect one, the probability of getting that product from machine A is 0.1644. Therefore, this is how we are using the total probability law and the Bayes theorem in the practical approaches. Here I have included two other exercises for you. Then you can just go through these two exercises as well and be familiar with these two concepts, the law of total probability and the Bayes theorem. And this is all what I need to discuss under this session. And thank you all for participating in this session.